Hey everybody, Dr. A here, and in this video we're exploring a simple example in differential leveling computations. So let's look at the given information. Here we're being asked to compute the elevation of point A if the benchmark elevation is 100 feet, and then we're told a back sight of 8.42 feet and a foresight of 1.20 feet were recorded. So a couple of vocabulary words that we need to remind ourselves of. When we say BM elevation, that means benchmark elevation, and this is the elevation of a known point in our process on our site. And we're being told that we know that its elevation is 100 feet. So let's go ahead and do a little sketch in our given information. If you notice, here is the benchmark, and here is my datum, which has an elevation of 0 feet. So all this is given. Now in red, I'm going to start drawing some solution components here. So where is the benchmark elevation? Well, this is this elevation right here. Remember, the benchmark elevation is the distance from some reference axis we call the datum up to the ground surface at that point. So this right here is 100 feet, okay? That 100.00 feet if we want to be more exact by our given information, okay? Now, what we're looking for, what we want to find is this elevation right here. And I'm going to call this ELEV sub A. That's what we want to find, okay? Now, remember, the instrument we're going to assume is set up approximately halfway in between our 2 points, the point that we know and the point that we're trying to find. So I'm just going to go ahead and use this figure already to go ahead and sketch some important information. So here is my auto level, and here's my tripod, okay? So if you watch the previous video, what happens first? Well, a rod person stands and places a Philadelphia rod on the point where we know the elevation. So for this example, that's going to be the benchmark, and takes a back sight. When the instrument person takes a back sight to the rod person here, what they read, this number that they read right here, that is the back sight value. So this distance right here is the back sight. Okay, so that's going to be the BS equaling to 8.42 feet. Okay, and then what happens after that's done, the rod person picks up the rod and moves it to the new point. Okay, so we're going to move this rod over to point A, and then the person standing at the instrument, called the instrument person, is going to swivel the auto level around and take a foresight. The foresight is going to be the reading that they take off of the rod when it's at the new point, the second point. And so the foresight reading is this value right here. That's the foresight, and that was given to us as 1.20 feet, okay? And so we use these values to calculate the elevation of point A, this elevation here that we're looking for. So under solution, the first thing I can do is calculate the height of the instrument, which is going to be the elevation of the benchmark plus the back sight. So that's going to be 100 feet plus 8.42 feet. And of course, that's just 108.42 feet. So that height of instrument is this height right here. It's from the datum to the line of sight of the instrument. Okay, and again, if you like seeing things graphically, you can think of it as this 100-foot dimension line plus this 8.42-foot dimension line. Okay. Then finally, we can say the elevation of point A, which is this dimension that we're looking for here, is going to be equal to that height of instrument minus the foresight value. So we're going to say that's 108.42 for 2 feet minus 1.20 feet, and you should get 107.22 feet, okay? And so from a dimension perspective, we say that HI minus this little distance is foresight, and what you're going to have left over is the elevation of point A, and then that is the answer that we're actually looking for. So you can, you can just kind of remember how to perform these calculations here using these equations, or what I suggest is really try to understand it by drawing a nice diagram and helping yourself visualize what's going on. So that's the conclusion of this video. If you found it helpful, please hit like and subscribe.